Hello everybody, welcome to part 5 of Learn Everything We Can Possibly Learn from Apple's VisionOS documentation. We are moving along and we are here to learn more about SwiftUI, presenting windows and spaces. Here is how we're going to open and close the scenes that make up your app's interface. An app's scene, which contains views that people interact with, can take different forms. For example, a scene can fill a window, a tab in the window, or an entire screen. Some scenes can even place views throughout a person's surroundings. How a scene appears depends on its type, the platform, and the context. When someone launches your app, SwiftUI looks for the first window group, window, or document group in your app, declarations, and open a scene of that type, typically filling a new window or the entire screen, depending on the platform. For example, the following app runs in macOS, presenting a window that contains a mail viewer view. Here's a struct called mail reader, and our first view is going to be mail viewer. In VisionOS, you can alternatively configure your app to open the immersive space. Then the app declares. In any case, specific platforms and configurations enable you to open more than one scene at a time. Under those conditions, you can use actions that appear in the environment to programmatically open and close the scenes in your app. Next, check for multi-scene support. If you share code among different platforms and need to find out at runtime whether the current system supports displaying multiple scenes, read the support multiple windows environment value. The following code creates a button that's hidden unless the app supports multiple windows. Here we have struct new window button, and if we support multiple windows, this particular platform, then we will open the mail viewer. The value that you read depends on both the platform and how you configure your app. In macOS, this property returns true for any app that uses the SwiftUI app lifecycle. In iPadOS and VisionOS, the property returns true for any app that uses SwiftUI's app lifecycle and has the information property key. UI applications support multiple scenes set to true and is false otherwise. For all other platforms and configurations, the value returns false. If your app only ever runs in one of these situations, you can assume that the associate behavior and don't need to check the values. Enabling multiple simultaneous scenes. You can always present multiple scenes in macOS to enable an iPadOS or VisionOS app to simultaneously display multiple scenes, including immersive spaces, scenes in the VisionOS. Add the UI application support multiple scenes key with a value of true in the UI application scenes manifest dictionary of your app's information property list. Use the info tab in Xcode for your app target to add this key. All right, let me go there directly from a particular application. Let's take a look at world, for example, and we'll go to world here, info, application scene manifest, and enable multiple windows. This is, of course, set to true. All right. Apps on other platforms can display only one scene during their lifetime. Okay, open Windows programmatically. Some platforms provide built-in control that enables people to open instances of Windows-style scenes that your app defines. For example, in Mac OS, people can choose File, New Window from the menu bar to open a new window. SwiftUI always provides ways for you to open new windows programmatically. To do this, get the open window action from the environment and call it with an identifier, a value, or both to indicate what kind of window to open, optionally what data to open it with. The following view opens a new instance of the previous defined mail viewer window when someone clicks or taps the button. Here we have the open window, and we open the particular window with the ID mail viewer. When the action runs on a system that supports multiple scenes, SwiftUI looks up for a window in the app declaration that has a matching identifier and creates a new scene of that type. Important: if support multiple window is false and you try to open a new window, SwiftUI ignores the action and logs runtime error. Well, that's not good. In addition, to open more instances of an app main window, as in the above sample, you can also open other window types that your app the body declares. For example, you can open an instance of the window that displays connectivity information. Here's a button that opens connection information. Now, open a space programmatically. In VisionOS, you can open an immersive space, a scene that you can use to present unbounded content in the person's surrounding. In much the same way you open a window, except that you use the open immersive space action, the action runs asynchronously, so you will use an await keyword when you call it, and typically do so from inside a task. Here's a task, await, open immersive space, orbit. I think we've seen this in the Hello World app. Because your app operates in a full space, when you open an immersive scene, you can only open one scene of this type at any time. If you try to open a space when one is already open, the system logs a runtime error. Your app can display any number of windows together with an immersive space. However, when you open a space from your app, the system hides all the windows that belongs to other apps. After you dismiss your space, the other app's windows reappear. Similarly, the system hides your app's windows if another app opens a immersive space. Okay, from reading that, it says you can open an infinite number of windows with your immersive space. However, when you open a space from your app, the system hides all the windows that belongs to other apps. After you dismiss your space, the other app's windows also all reappear. Similarly, the system hides your app window if another app opens an immersive space. So this goes into details about how immersive space takes over entire space. Designate a space as your app's main interface. When VisionOS launches an app, it opens the first window group, window, or document scene that's the app body declares, just like any other platform. This is true even if you first declare a space. However, if you want to open your app into immersive space directly, specify a space as the default scene for your app by adding UI application preferred default scene session role key to your app's information property list and settings its value to UI scene session role immersive space app. In that case, VisionOS opens the first space that it finds in your app declaration. Be careful not to overwhelm people when you start your app with immersive space. So follow design guidelines for more immersive space experiences. Here we can take a look at this. Launch in immersive space. Let's see. Let's do an add and then launch immerse scene in immersive space. Maybe immersive. Let's look that up. Give me a moment. UI application. No, that's not it. UIC. Nope, that's not it either. I can't seem to find it. Give me a pause. All right, I looked it up. It's in scene configurations under application scene manifest, immersive space application session role. And maybe we do an add in here as well. Looks like there's an item 1. Not exactly sure yet what it is, but I think that's it. We'll look into it a little later. Okay, close windows programmatically. People can close windows using system controls like the close button built into the frame around a macOS window. You can also close windows programmatically, get the dismiss window action from the environment, call it using an identifier of that window that you want to dismiss. Very simple, add an environment, the path dismiss window, and we call dismiss window of this particular ID. In iPadOS and VisionOS, the system ignores the dismiss action if you use it to close a window that's your app's only open scene. That's reasonable. So if that's the only window you have open, you can't dismiss it. Close spaces programmatically. To close a space, you call the dismiss immersive space action like the corresponding open space action. To close actions operating asynchronously requires the word await keyword. dismiss immersive space, and we task await dismiss immersive space. Very, very straightforward. We've seen this in Hello World. You don't need to specify an identifier for this action because there can only ever be one space open at a time. Like with Windows, you can't dismiss a space that your application opens. Transition between a window and a space. Because you can't programmatically close the last open window or immersive space in a VisionOS app, be sure to open a new scene before closing the old one. Pay particular attention to the sequence when moving between a window and immersive space because the space open and dismiss action runs asynchronously. For example, consider a chess game that begins by displaying a start button in a window. When someone taps the button, the app dismisses the window and opens immersive space that presents a chessboard. The following button demonstrates proper sequencing by opening the space, then closing the window. Let's take a look at that. Button, start, task, open immersive space, then dismiss the window start. This runs after opening the immersive space. In the above code, it's important to include dismiss window action inside the task so that it waits until the open immersive space action completes. If you put the action outside the task, either before or after, it might execute before the asynchronous open action completes, when the window is still the only open scene. In that case, the system opens the space but does not close the window. All right, that was great. We learned a lot about presenting windows and spaces, how to open them and close them, transitioning between them, and designating which space to use or a window to use. All right, I think that is good. We also learned about opening up multiple spaces. Let's take a look at positioning and sizing windows next. Positioning and sizing windows influence the initial geometry of windows that your app presents. VisionOS and macOS enables people to move and resize windows. In some cases, your app can use scene modifiers to influence a window's initial geometry on these platforms, as well as to specify the strategy that the system employs to place minimum and maximum size limitations on a window. This kind of configurations affect both windows and volumes, which are windows with volumetric window styles. Your ability to configure window size and position is subject to the following constraints. The system might be unable to fulfill your request. For example, if you specify a default size that's outside the range of the window's resizability, the system clamps the affected dimensions to keep it in range. Although you can change the window's content, you cannot directly manipulate the window's position or size after a window appears. This ensures that people have full control over their workspace. During state restoration, the system restores windows to their previous position and size. This tells us that we should set our limits properly so that we can give the user a control, but not too much control over the size of our windows. Windows in iPad OS occupy the full screen or share the screen with another window in slidovers or split views. You cannot programmatically affect window geometry on the iPad. Specify initial window position. In macOS, the first time you open your app and open a window from a particular scene declaration, the system places the window at the center of the screen by default. For scenes types that support multiple simultaneous windows, the system offsets each additional window by a small amount to avoid full obscuring existing windows. You can override the default placement of the first window in the macOS by applying default position scene modifier to indicate where to place the window relative to the screen's bound. For example, you can request that the system place a new window in the bottom trailing corner of the screen. Bottom trailing, at the bottom of the screen. To the right. The system aligns the point in the window that corresponds to the specific unit point with the point in the screen that corresponds to the same unit point. You can use a built-in unit point like bottom trailing in the above example, or use a custom one. Well, here's some important information. You cannot use default position in VisionOS. The system always places the windows directly in front of people where they happen to be looking at the moment the system opens. This helps make people aware of new windows. Specific initial window size. You can indicate a default initial size for a new window that the system creates from a scene declaration by applying one of the following default size scene modifiers, like default size, width, and height. For example, you can request that the new window that a window group generates occupy 600 points in X and 400 points in Y, as seen here, with a default size modifier of a CG size 600 and 400 height. The system might clamp the actual size of the window depending on both this window content and resizability settings. Specify Windows resizability. Both Mac OS and VisionOS provide interface controls that enables people to resize windows within certain limits. For example, people can use the controls that appear when they look at the corner of the VisionOS window to resize a window on the platform. Here, let's look at this video where you touch this is, I think, the bottom trailing corner, and it's not playing. That's okay. We'll just move on. You can specify how the system limits window resizability. The default resizability for all scenes is automatic. With that strategy, setting windows use the content size strategy, where both the minimum and maximum window size match the respective minimum and maximum size of the content that the windows contain. Other scene types use content min size by default, which retains the minimum size restriction, but does not limit the maximum size. You can specify one of these resizability strategies explicitly by adding the window resizability modifier, scene modifier, to a scene. For example, people can resize windows from the following window group to be between 100 and 400 points in both dimensions because the frame modifier imposes those bounds on the content view. Here's a scene modifier frame on content view, and we have a minimum width of 100, maximum width of 400, minimum height of 100, and maximum height of 400, and we set the window resizability to the content size. You can take this even further and force a specific size for a window with a content that has a fixed size. Now, lastly, specify a volume size. When you create a volume, which is a window with the volumetric style, you can specify the volume size using one of the 3-dimension default size modifiers, like the default size, width, height, and depth in a particular measurement system. The following code creates a volume that's 1 meters on a side. Here's a globe, and we have a default size of 111 in meters. The volume maintains the size for its entire lifetime. People cannot change the size of a volume at runtime. Although you can specify a volume size in points, it's typically better to use physical units like the one above, which specifies a size in meters. This is because the system renders a volume with fixed scaling rather than dynamic scaling, unlike a regular window, which means the volume appears more like a physical object than a user interface. For information about different kinds of scaling, see spatial layouts. Wonderful. With that, we are done with all of the SwiftUI content in the documentation. We will be moving on to Reality Kit and Reality Composer Pro and learning about Splish Splash next time. Looking forward to it.